Good day. My name is John Vincent Sarkanlao. This channel is about research and research statistics. Our topic for today is inferential statistics, t-test, one and two-tailed test. First to consider is to making a testing table. So this is our testing table. We have our hypothesis. We have one-tailed and two-tailed. I'll be using, well, it's only like this because it's for the table, for the example that we'll use later. So for the one-tailed, it's regular is greater than irregular, and for two-tailed, regular is not equal to irregular. Then we have our test of hypothesis, which will be using our mean, and we have our p-value, our level test of whether it's significant or not. You'll be using the p-value. So first we need to do is our copy our data. So we have monthly checkup. We will be using monthly checkup because we're doing a t-test. And t-test you only use two groups. And we have groups for regular monthly checkup and irregular monthly checkup, and we will be pairing it with this variable reproductive health. Okay, reproductive health. So put it there. Then we need to solve for the mean, because since we're doing a t-test, we're only measuring two variables. So we have, let's average. We solve for the average first of reproductive health. Okay, so that equals to average, then open parentheses, then highlight the scores you want to get the average with, and you paste it down so that it will automatically count the average which for each respondent on their reproductive health. There. Then what we need to do is to copy everything here and there. Copy and paste values. So it's only now values. If you notice, there's no formula bar already. So what you need to put them to 2 decimal places. Okay, so 2 decimal places. There. So we have no longer need for this one, so we can delete this one. Okay. So this is the average reproductive. So next we'll increase our view for a while. Increase our zoom selection. Zoom. Let's go to it. Okay. So we have now our group, our responses. We have the monthly checkup, which is your independent variable, and your dependent variable is average reproductive health. What we need to do now is to sort. So highlighting the responses, then click sort and smallest to largest. Always remember to expand selection so that I'll explain first. So here we'll highlight that one so that when we expand selection, This response of respondent number 1, who goes with regular monthly checkup and the average of reproductive health of 375, is still consistent as we sort the data. Okay, then we sort and largest to smallest. That's it. So it's still here. It didn't, the line did not change at all. Next is to group them. So we have regular, and irregular. In a t-test, you have to be conscious. As in early videos, I've already told about progression of responses. There is a assumption that code 2, we code it as 2, meaning 1 is greater than the other, 2 is greater than 1, or regular is greater than irregular. As I've said, this responses is nominal, and we have to put some sense of order in it. So we considered 2 as greater than 1, or regular is greater than irregular. And we have to put on the first column what is assumed to be higher, even if it's a nominal data. So it's 2, and place it here, there. So those 2, meaning those who goes to a regular monthly checkup, these are the average reproductive health of those who has regular monthly checkup. And this who has irregular monthly checkup, these are their average reproductive health. Okay. So we have now our groups. We only have 2 groups, regular and irregular, and that's and in t-test you only have 2 groups when you compare. Next is we have to test statistics. So we have data. As you can see here, there is also a data analysis button, but it's not always. So to activate that one, it's already activated, but to activate that one, you just click on File, Options, Add-ins, and you click on Analysis Toolpack. Then you click OK. Once you click OK, the data analysis button will be there. Now we will be doing the calculations. So we'll be using t-test. So we have analysis tools, we have everything here, and we'll be using t-test. Actually, you can use equal variance and unequal variance. For equal variance, you will have a pool variance, but I would like to use unequal variance simply because we don't know the variance of the results first. So I will just assume that their variances are unequal. Okay, so first, it's very important that in variable 1 or range 1, what is assumed to be higher. And as I've said in previous video, you have to have that certain degree of landscape model, or you arrange them. Even if it's nominal, you have to set assumption which is higher or lower, greater or least. Then hypothesize mean difference is 0. Then we click labels on first row. The alpha, the level of significance, is at 0.5, which is at default. Then we click on output range, and we click here click it first here, and you'll click on the area you want to place it, then click OK. So now we have our results. This is very important. You notice that there is a negative t here, negative t. This is because the second variable is higher than the first variable, and if you didn't arrange them, you will have this result. We'll just interchange them just to show you the difference. So let's say you used irregular first, the first column, irregular first in the first column, and regular on your second column, and your output range is here. Let's move the other side. Range here. Here, there. So you notice that the t-stat is already positive. So if you didn't have that assumption, it's gonna confuse you later on. So that's very important that you put in column A or range A what is assumed to be higher, even if it's a nominal data. And actually the rest are just the same. It's just inverted. So right now we'll be testing the hypothesis. So there is regular greater than irregular. It's false, meaning irregular is greater than regular. Then is regular not equal to irregular. Regular not equal to irregular. That is true. The question now is it significant or not? So first we have to test our probability value of our one-tailed. Our one-tailed probability value is this one. The probability value. Is it lesser than 0.05, which is our parameters? Where did we get 0.05? So that's the 0.05. If the number is less, 0.4, 0.3 and lesser, it's considered significant. However, if the values is 0.6, 0.7, 0.8, it's not significant. And this one for our two-tailed test. Our p-value is lesser than 0.05. False. So basically our findings here will say that the reproductive health of those with irregular monthly checkup is greater than those with regular monthly checkup, and the difference is significant. That is our findings, meaning it is very possible that this one can be false, meaning reproductive health of the irregular is greater than regular, but the difference is not significant. And for this one, there is no significant difference in respondents' reproductive health when grouped according to monthly checkup. Because here, looking at our p-value here, it's around 0.6. So here, categorically, it's not significant anymore. So that's it. So that's how you solve for your t-test. One-tailed and two-tailed tests. So I hope you learned something from this video. Please remember to like, share, and subscribe. Thank you and good day.